In this video, we're going to work through the problems that you will find in the Chapter 10 lecture slides. Most of this chapter is kind of reading and comprehending the material. There aren't a whole lot of problems until you get to the end. So that's what we're going to work through now, these concentration calculations. So you've got a table of the different types of concentration calculations that we will do. You'll always have access to that table, just being able to use the correct equation at the correct time. So the examples we have here, the first one is to calculate parts per million. And parts per million is always going to be equal to grams of solute over grams of solvent. And because we're doing parts per million, we're going to multiply by 1,000,000, which is 10 to the 6th. Grams of solute, solute's always your smaller quantity. So that's going to be the 0.055 grams of copper in this case. Solvent is the larger quantity, which is the 250 milliliters, but we need grams. So water, the density is 1 gram is equal to 1 milliliter. So that means 250 milliliters of water is going to be equal to 250 grams of water. So that's an easy conversion and something that you're going to want to remember. So we're going to have 250 grams of solvent in this case. Then we will multiply by 1,000,000 to get our final answer, which is going to be 220. The next example, we have parts per billion. So very similar, we're going to have grams of solute over grams of solvent. But this time we're doing parts per billion. So we're going to multiply by 1,000,000,000, which is 10 to the 9th. So again, we'll have 0.055 grams over 250 grams, this time times 10 to the 9th. So this answer will be 220,000 parts per billion. Next one, percent by mass, again is going to be grams of solute over grams of solvent. Percent by mass you can think of as parts per 100. So we're multiplying by 100, just like you would to do any kind of percentage calculation. So now we're going to have 0.055 grams over 250 grams times 100 this time. So here we're going to get 0.0022%. So notice for all of these, we've got grams of solute over grams of solvent. The difference is the factor of 10 that you will multiply by. For parts per million, you multiply by 1,000,000. Parts per billion, multiply by 1,000,000,000. Percentage, we're multiplying by 100. This last example, grams per milliliter, is just that, grams per milliliter. So we're going to do grams of solute over milliliters of solvent. This time there is no factor of 10 to multiply by. So we've just got 0.055 grams over 250. In this case, we're doing milliliters. And our answer is 2.2 times 10 to the negative 4th. So each of these concentrations are very similar. Which one is used just depends on how small the concentration is. We always want to be using numbers that are easy to work with. So this 2.2 times 10 to the negative 4th is a pretty tiny number versus thinking about 220 with the parts per million calculation. The other concentration that you're going to want to be able to calculate is molarity. Molarity is always going to be moles of solute over liters of solution. So this means you're going to be able to need to be able to calculate moles. And for calculating moles, if you are given grams, which will be the common thing in a problem, it's going to be grams. And then you're going to need the molecular weight, which we calculated back in chapter 7 when we were doing London forces and estimating the size of our molecule. Remember, grams per mole were the units of molecular weight. So we're going to flip that, think of it as a conversion factor, and get moles from grams. So we're starting off with 5 grams of sodium bromide, and want to know how many moles that is. So first we need the molecular weight of sodium bromide. So this is where you need to look at the periodic table and get the mass of each individual atom and add them up. So sodium is 23 grams per mole, and bromine is 80. So we add that up and we get 103 grams per mole. So we always start with what we're given, the 5 grams, and we want to convert that to moles. So we're going to put the 1 mole on top, and that is equal to the 103 grams on the bottom. So here our answer is going to be 0.05 moles. Okay. So now to use that to actually calculate concentration in molarity, the second half here, again, we've got the 5 grams, which we've already converted to moles, and we're going to put that into 500 milliliters of water. Molarity is moles of solute over liters of solution. We have the moles of solute from the previous step, but we need to get liters from milliliters. What we need to remember here is that 1,000 milliliters is equal to 1 liter. So if you're given milliliters, you need to divide by 1,000. So that means 500 milliliters is equal to 0.5 liters. Now we've got our volume in liters and our quantity in moles for the solute. So we'll take the 0.05 moles divided by 0.5 liters, and that gives us 0.1 molar. So the big M, which is the unit for molarity, we call that molar. So that's your answer for that problem. Then we have a couple more examples. Percent by mass again, grams per milliliter, and another molarity problem. So this problem we're given 600 milliliters of water that has 7.5 grams of magnesium chloride. Remember, percent by mass, we're going to use grams of solute, so 7.5 grams over grams of solvent, solvent, which is 600 milliliters is going to be equal to 600 grams because we're dealing with water. So we'll take the 7.5 grams and divide it by 600 grams. For percentage, we multiply by 100. Our answer to this problem is 1.25%. Grams per milliliter, we're going to divide the 7.5 grams over the 600 milliliters. No factor to multiply by, so we get 0.0125 grams per milliliter. Then the last example here is molarity. For molarity, the first thing we need to do is calculate our molecular weight. So you've got magnesium chloride. Magnesium is 24 grams per mole. Chlorine is 35.5, and we have 2 of them. So if we add all of that up, we come up with 95 grams per mole. If we take the 7.5 grams that we're starting with, we will divide that by the 95 grams per mole and come up with 0.08 moles. We also need liters. The 600 milliliters is equal to 0.6 liters. So now we have what we need to calculate molarity. We'll take the 0.08 moles and divide by the 0.6 liters, and we will get 0.13 molar as the answer. So there are your problems from Chapter 10 lecture slides.